Number 10 says, evaluate the limit in two different ways. Okay, we have the limit as x approaches 2 of 10x squared minus 40 divided by 7x minus 14. The first thing that I'm going to do is perform direct substitution by plugging 2 into my limit. So 10 times 2 squared minus 40 divided by 7 times 2 minus 14. That's going to be 0 over 0, which is indeterminate. Because this is indeterminate, I'm going to have to solve my limit by using rules of algebra. Or I can use L'Hopital's rule. I'm going to start off with using L'Hopital's rules first, then I'm going to use algebra second. L'Hopital rule says if we have the limit as x approaches a of f of x divided by g of x, and this limit equals to 0 over 0 or infinity over infinity. Both of these are indeterminate forms. Then we can say that the limit as x approaches a of f of x divided by g of x is equal to the limit as x approaches a of f prime of x divided by g prime of x, such that f and g are both differentiable functions. So that means we can take the derivative of the numerator, derivative of the denominator, and then reevaluate the limit. So let's go ahead and do that. I'm going to take the derivative of my numerator and the derivative of my denominator. And when I do that, that is going to be the limit as x approaches 2. The derivative of 10x squared is 20x. The derivative of 40 is 0. The derivative of 7x is just 7. The derivative of 14 is 0. Now we can reevaluate the limit. So that's going to be 20 times 2 over 7. That is going to equal to 40 over 7. All right. Now, that's using L'Hopital's rule. The second way I'm going to do it is by factoring. Okay. We're going to have the limit as x approaches 2. In my numerator, I'm going to factor out the 10. If I factor out the 10, I'm going to be left with x squared minus 4 inside parentheses. In my denominator, I'm going to factor out the 7. So I'm left with x minus 2 in the parentheses. I'm going to continue to factor my numerator as well. If we factor x squared plus x squared minus 4, that is the difference of perfect squares. And that can be factored into x minus 2 times x plus 2. The x minus 2's simplify each other out. So now we're left with the limit as x approaches 2 of 10 times x plus 2 over 7. Perform direct substitution. 10 over 2 plus 2 divided by 7. That's going to equal to 40 over 7. And that is how you solve the limit in two different ways. All right, let's move on to 10b. It says the limit as x approaches infinity of 10x squared minus 40 over 7x squared minus 14x. We can do this in two ways as well. I'm going to use L'Hopital's rule if I have an indeterminate answer. So we plug in infinity. 10 times infinity squared minus 40. 7 times infinity squared minus 14 times infinity. If you look here in my numerator, this is going to be an indeterminate. This is infinity. My denominator, that's infinity minus infinity. But we already said that infinity minus infinity from before when we did limits at infinity. This is also indeterminate. Because this is indeterminate, that means this entire fraction is indeterminate. So I can either use the leading term principle or I can use L'Hopital's rule. I want to use L'Hopital's rule first. I'm going to take the derivative of my numerator and denominator. So limit as x approaches infinity. That's going to be on top 20x. On the bottom, that's going to be 14x minus 14. Plug in infinity. 20 times infinity divided by 14 times infinity minus 14. This is still infinity over infinity. This is indeterminate. So we're going to do L'Hopital's rule again. Take the derivative of the top, take the derivative of the bottom. We have the limit as x approaches infinity. The derivative of 20x, that is just 20. The derivative of 14x, that is 14. Minus the derivative of 14 is 0. Remember, the limit of a constant is just the constant. So this is going to be equal to 20 over 14, which can be reduced to 10 over 7. And that is our answer. Doing this the second way, I'm going to use the leading term principle because I have a limit as x approaches infinity. So if I use the leading term principle, LTP, that's going to be the limit as x approaches infinity of the leading term in the numerator. The leading term in my numerator is going to be 10x squared. The leading term in my denominator is 7x squared. As we can see here, the x squared simplify each other out. The limit as x approaches infinity of 10 over 7. And once again, the limit of a constant is the constant. That is 10 over 7. All right, guys, that is it to this video. Once again, I can use L'Hopital's rule to evaluate an indeterminate answer. If I can factor, you should try to factor as well. Factoring will make life a little bit easier. And I'll catch you in the next one. Take care.